So we have a matrix equation set up right over here. We have matrix A times this plus matrix B times this plus matrix C times this is equal to this 2 by 2 matrix. And the way it's set up, it's a little bit of a puzzle, and I'll give you one clue as to what type of matrices A, B, and C could be. They're each either going to be an identity matrix, or a zero matrix. So given that clue that each of these are either an identity matrix or a zero matrix, can you pause this video and essentially solve this puzzle? Which of these are identity matrices and which of these are zero matrices? I'm assuming you've given a go at it. So let's go entry by entry. So if you look at this first entry right over here, how can we get a 2 for this top left entry? Well, let's see. When we multiply, if any of these are identities, then essentially you just get the value of the matrix. If any of these are 0, then essentially that product doesn't get added. It's one way of thinking about it, is that matrix won't matter anymore because it's going to be multiplied by 0. So if A was a 0 matrix and B and C were identity matrices, you would add 1 plus 1 to get 2. So you're like, oh, maybe that's the case. But it could be the other way around. It could be that A is identity matrix, B is a 0 matrix, and C is an identity matrix, and you add 1 plus 1 over there to get 2. Or you could say that maybe C is the 0 matrix and B is the identity matrix, and you add 1 plus 1 here. So really all this is telling us is two of A, B, and C are going to be identity matrices, and one is going to be a 0 matrix, but we don't know which one is which just yet. Any of them can be the 0 matrix, at least based on looking at that first entry. Now let's look at, let's look at this entry right over here. How can we add up to 4? Well, let's see. 3, if this was an identity matrix and this was an identity matrix, then then essentially you'll just be left with this matrix plus this matrix, and this is going to be the 0. So 3 plus negative 5, that is not equal to 4. So both of you can't have A and B be identity matrices and C be the 0 matrix. So let's think about other combinations here. So what about B and C being the identity matrices and A being the 0 matrix? In that situation, so A is the 0 matrix, so that's not going to matter. And we're essentially, when you multiply B times this, you're just going to get this matrix, and C times this, you're going to get that matrix, if B and C are identity matrices. And so you have negative 5 plus 1 would be negative 4. So that doesn't work either. So our last scenario is going to be, so we can essentially rule out B as an identity matrix, because when we had B be one of the identity matrices and we picked the other two options, we still couldn't get to 4 here. So B is going to be a 0 matrix, and let's see if that works out. A is identity, then A would be an identity, and C would be an identity matrix as well. So let's see if that actually makes sense. So if this right over here is identity matrix and that over there is an identity matrix, this whole thing simplifies to 1, 3, 4, comma negative 2 plus 1, 1, 3, 2. And it does indeed equal 1 plus 1 is 2, 3 plus 1 is 4, 4 plus 3 is 7, negative 2 plus 2 is indeed 0.